Welcome, everyone, to the very first episode of the Modularity Podcast.
We are excited to kick things off and finally share this project with you. This has been something we've been cooking up for a while now.
Yeah, it's been in the works for a bit.
We always wanted to build a show that dives deep where it matters, things like the history, the context, and the tech that shapes the internet as we know it today.
Exactly. So I think it makes sense to talk about what this podcast is about. This first season of the Modularity Podcast is called The History of the Internet, and that title captures the goal to trace the interconnected stories, breakthroughs, and people that shaped the digital world we live in today.
Right? It's about breaking down big, complex ideas like the evolution of the web into smaller, understandable parts, and then showing how they connect to form the digital world we live in.
And that's where we come in. Each episode, we're taking on a chunk of that bigger story. It's history, it's technology, it's culture, and honestly, how all of those things intersect.
I think we're more interested in peeling back the layers and asking questions like, how did we even get here?
Mm-hmm.
You know, what are the big turning points that actually shaped the internet and really shaped everything from the way we communicate to how businesses run today?
And where better to start than at, well, the beginning? Episode 0 today is all about laying the groundwork. We're going to talk about how World War II, a massive global conflict, sparked the early seeds of what would eventually become modern computing and even the internet.
Yeah, it's not the typical starting point most people think of, right?
Right.
When folks talk about the internet, they jump straight to, I don't know, the 90s maybe? Dial-up connections, AOL CDs.
Oh man, those CDs were everywhere. Like, you couldn't escape them. We used them as drink coasters. But no, we're pushing things way further back.
Right. We're rewinding to Alan Turing, the Enigma machine, and what really stands out to me here, the importance of collaboration. I mean, it wasn't just one person cracking codes in isolation. It was teams of minds, methods, and ideas coming together.
And those breakthroughs, they weren't just about winning the war. They laid the foundation for this modular, collaborative way of thinking that still drives innovation today.
Exactly.
So yeah, strap in. Episode 0 is going to set the stage for everything moving forward.
It's the historical piece of the puzzle that will make everything else we discuss, well, make sense. Let's dive in.
All right, so let's talk Enigma codes, cryptography, and Turing's Bombe machine. I mean, this period, it's fascinating, isn't it? We're in the middle of a world war, and you've got mathematicians trying to outthink Nazi technology with, what seems like impossibly complex puzzles.
Yeah, and the Enigma machine wasn't just some beginner-level cipher device. It created these insanely layered encryption systems. Every rotated rotor, every plugboard connection, all of it added more complexity. To the Germans, it seemed like their messages were, invincible.
Right. Invincible being the key word there, or so they thought. Enter Alan Turing and his team at Bletchley Park. What blew my mind when I first read about this was that they didn't go at it with today's, computerized approaches. We're talking early electromechanical machines designed to guess and test millions of possibilities at speed.
Exactly. And central to that was what became the bombe. So picture this. It's this tall, boxy machine filled with rotating drums. Each drum simulated the action of an Enigma rotor, checking combinations rapidly, thousands of them, so they could find the secret daily settings in time to actually use the information during wartime.
And it wasn't just brute force, right? There's this method to the madness. They'd use these cribs, which were basically known snippets of plain text or weather reports. The bombe would use those to work backwards. And because Enigma couldn't, match a letter to itself, that gave them a crack to exploit.
Yeah, the no letter to itself rule was a fatal flaw. Germany just didn't realize they'd baked into the system.
Right.
And once Turing and the team exploited it, it wasn't immediate, but the bombe turned days or weeks of manual code breaking into something manageable within hours that was game-changing.
It really redefined cryptography. And beyond that, the scope of what machines could do. Suddenly, computation wasn't just about mathematical theory anymore. It was solving life and death situations. And people, teams of people, like the Women's Royal Naval Service, the Wrens, were keeping these things running 24/7.
Yeah, it was a total team effort. I mean, Turing often gets a lot of the credit, deservedly so, but there were, hundreds of analysts and operators in these cramped huts at Bletchley Park.
Wow.
The collaboration there was this perfect storm of innovation meeting necessity.
And that collaboration, it's one of those lessons that transcends the historical context. Like, okay, yes, their work dismantled German strategy and shaved years off the war, but it also created this blueprint for how to tackle big, complex problems, modular, team-driven, and methodical.
Right, and that modular approach, trial and error, breaking down those processes into steps, that all echoes into modern computing.
Right.
The bomb might have been clunky and electromechanical, but it paved the way for programmable hardware, which, well, that's another story in itself.
Totally. Still, what Turing and the bomb machine proved was that innovation doesn't wait for perfect tech. Sometimes you work with what you've got and make it revolutionary. That's what drove cryptanalysis into the future, and it's what planted the seeds for what the internet world would build on.
Yeah, it was human ingenuity meeting machine logic in its earliest form, and here we are, decades later, standing on that foundation. Turing and his team didn't just break codes, they built a new way to think.
All right, so here's a name more of us really ought to know, Grace Hopper. Dave, I mean, where do we even start with her? She's got this incredible story that's equal parts coder, trailblazer, and honestly, just plain tenacious.
Definitely. I mean, Grace Hopper wasn't just working with computers, she was shaping what programming even meant. We're talking about the person who essentially invented the idea of a compiler, which allowed computers to understand higher level instructions instead of just raw code.
And for those of us not knee-deep in coding, a compiler is what makes your modern apps and software possible. Hopper's idea actually made programming accessible.
Exactly. Before Hopper, programs had to be written purely in machine code, which is basically strings of numbers. Think binary. Her invention took that process and said, no, let's create translations between human-readable languages and computer language. It was absolutely groundbreaking at the time.
What I think is so wild, it wasn't just the technology she revolutionized, it was how people thought about coding. Hopper was all about making it inclusive, right? She believed that coding shouldn't be this exclusive club of mathematicians. And she actually made it understandable, even, approachable.
Right? And that's where her work on Flowmatic and later COBOL comes in. These were languages built using actual English words, opening up coding to a much broader audience, and honestly paving the way for software development as we know it.
Flowmatic, it's like the ancestor of COBOL, huh? Which, by the way, is still being used for banking systems like today. Think about that. Hopper helped create something that's been operational, 7 decades later?
Wow.
It's incredible how something so early could have such staying power.
Yeah, and COBOL wasn't just useful. It was revolutionary. Businesses could suddenly standardize processes, make their systems scale globally, and build stability into their operations. But this wasn't by accident. Hopper was methodical, but she also listened. She understood what programmers and businesses actually needed.
And her debugging anecdote, absolute gold. There was an actual moth that got stuck in one of her computers, right? And then coined the term debugging when she fixed it, literally pulling out the bug. It's such a perfect snapshot of her, what's the word, irreverent, but like deeply collaborative style.
Oh, for sure. And that story just encapsulates her personality. She had this knack for cutting through the complexity and making things work, right? And beyond all the tech, she was also an educator at heart. She always said her biggest accomplishment was inspiring younger generations.
Wow.
It's amazing how she prioritized people as much as the technology itself.
Amazing Grace, right? The nickname she picked up in the Navy, and honestly, it fit when you think about it. She wasn't just revolutionary in tech. She broke down barriers as a woman in spaces that were, let's be honest, usually dominated by men.
Yeah, she served in the Women's Naval Reserve during World War II and stayed connected to the Navy her entire career. Even her contributions there were immense, standardizing military computer languages and shaping early systems used by the armed forces.
And really, her legacy is so much bigger than any single invention. Hopper's whole philosophy, making programming straightforward and inclusive, just resonates, you know? It's like she laid the foundation for what we now think of as tech for all.
Absolutely. She didn't just shape programming, she shaped how we interact with machines. Hopper believed that technology should empower people, not intimidate them. That vision still drives so much of what we build today. It's why her influence feels timeless, honestly.
So next time you boot up your laptop or write that tiny block of code, yeah, say a little thanks to Grace Hopper. Her work reminds us that tech is, at its core, a tool to connect, empower, and include. So, Dave, here we are, taking stock of everything we've talked about today, the breakthroughs, the people, the sheer ingenuity. What really stands out to me is how much of this wasn't, just about individual brilliance. It was about collaboration, systems working together, just like the people behind them.
Exactly. And what's interesting is the modular mindset they had, breaking a massive problem, like cracking Enigma, down into smaller, manageable pieces. So that's something we see echoed in tech to this day. I mean, think about the way we build software using microservices now, or even how the internet itself relies on distributed systems.
Right? It's like those early engineers were writing the playbook for managing complexity without even realizing it, and what I love most is how they didn't wait for the perfect tools. Turing and his team took what they had, the Bombe machine, limited resources, and they made it work. Honestly, it's a great reminder that innovation doesn't need perfection.
Right?
It needs creativity and perseverance.
Yeah, and that adaptability is key. Wartime innovation didn't have room for rigid processes. You had to pivot constantly. It's a mindset we still need today.
Exactly.
Especially in tech, where things evolve so quickly. If you're stuck chasing the perfect solution, you might already be too late.
And let's not forget the teamwork element. I mean, look at Bletchley Park or Grace Hopper's work. They both show how real breakthroughs happen when people bring different skill sets to the table. No one person cracked Enigma, and no one single-handedly redefined programming.
Right.
It was teams working in sync.
Right, and it wasn't just technologists and mathematicians. The Wrens operating the bomb machines, the naval officers coordinating logistics, they were all part of that bigger system. That's something we should carry forward. Valuing every piece of the puzzle.
Right.
Every person's contribution. Innovation isn't about lone geniuses, it's about collective effort.
Totally. And honestly, it's a lesson not just for tech, but like everything. Business, science, education, collaboration, breaking things into chunks, and staying flexible. That's how we solve the big problems.
Exactly.
It's clear that these wartime lessons gave us more than just computers. They gave us a framework for thinking.
Exactly. The systems we rely on today, everything from the web to the devices in our hands, they echo those early principles. Innovation is modular, collaborative, and frankly, a bit scrappy. If there's one takeaway from all this, it's that necessity doesn't just breed invention, it builds a foundation that lasts generations.
Couldn't have said it better. Like these wartime innovations, whether we're talking about code-breaking machines or the birth of programming, they remind us where it all started, and honestly, what's possible when we come together to solve something monumental. So, what does all this have to do with the internet? Well, you can't connect computers until you have them, and these wartime pioneers made that a reality. Their work didn't just end with the war. It evolved into the technology that would eventually make the internet possible.
As we wrap up this introduction to the history of the internet, we're left with a question. How did the early groundwork laid by these visionaries and the ambitions of Cold War era research spark the creation of the ARPANET, the foundation of our modern internet, of our...
That's exactly what we'll dive into next time on the history of the internet. In the meantime, if you're looking to build your own digital presence, reach out to us at modularity.us. Let's build a digital presence together, one that stands the test of time, just like these early innovations. We will see you in the next episode.